Myself, Kalshetti, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solapur. Today, I am going to discuss the AC circuits. Learning outcome. At the end of the session, students can analyze purely resistive and inductive circuits. Pure resistive circuit. Now, consider the above circuit in which AC voltage is applied across the R. Whenever the AC voltage is applied across the purely resistive circuit, during positive half cycle, current flows in one direction, and during negative half cycle, current flows in opposite direction. Means the alternating current flows through the circuitry and the voltage is developed across the R. This is the waveforms. This is for AC voltage and the AC current. Let the alternating voltage is applied across the circuit and it is given by the equation V is equal to Vm sin omega t, where V is the instantaneous voltage, Vm maximum peak value of the alternating quantity, and omega is the angular frequency. Okay. Now, whenever the AC voltage is applied across the circuit, the current flows through it. Therefore, according to the Ohm's law, I is equal to V by R. As we know, V is equal to Vm sin omega t. Therefore, I is equal to Vm sin omega t upon R. Therefore, Vm upon R sin omega t. Now, the value of current will be maximum when sin omega t is equal to 1. So, sin omega t is equal to 1 is possible when omega t is equal to 90 degree. Therefore, I is equal to Vm upon R. Therefore, this I considered as a maximum peak value. Therefore, Im is equal to Vm upon R. Therefore, I is equal to Im sin omega t and V is equal to Vm sin omega t. With help of these two equations, it indicates that the current is in phase with voltage and the phase difference is 0 degree. Now, this is the waveforms. Now, this waveform, the blue waveform, represents the voltage waveform and this waveform indicates the current waveforms. Okay, so now here voltage and current both are in phase, therefore the phase difference is 0 degree. Now here in the positive half cycle, the voltage and current both are positive, therefore power is positive, and during negative half cycle, V and I both are negative, therefore power is again positive. Expression for power. Now, instantaneous power P is equal to V into I. So, as we know, V is equal to Vm sin omega t, I is equal to Im sin omega t. Therefore, P is equal to Vm Im upon 2 into sin square omega t. So, with help of trigonometric equation, sin square omega t is equal to 1 minus cos 2 omega t divided by 2. Therefore, P is equal to Vm Im divided by 2 into bracket 1 minus cos 2 omega t. Now here rearrange the equations. So Vm by root 2 Im by root 2 minus Vm by root 2 Im by root 2 cos 2 omega t. Now this power equation consists of two parts. The first part is the constant part and the second part is the fluctuating part. Therefore, the average value of the power. Now the average value of the fluctuating component is 0. Okay, therefore, the average value of the power for one complete cycle is equal to Vm Im by 2. Now, this is the power waveform. During positive half cycle, voltage and current both are positive, therefore power is equal to Vm Im sin square omega t and the average power is equal to Vm Im by 2. And during negative half cycle, both are negative, so still power is positive. Example. An AC circuit consists of a pure resistance of 10 ohm and is connected across an AC supply of 230 volt 50 Hz. Calculate current, power consumed, equation for voltage and current. Okay. In this equation, the given parameters are R is equal to 10 ohm and the RMS input voltage is given. Vrms is equal to 230 volt. As we know, Vrms is equal to Vm by root 2. Okay, so with help of this equation, calculate first Vm. Okay, then omega is equal to 2 pi f is given. So calculate omega is equal omega with help of above equation. Omega is equal to 2 pi f. Now, so first calculate current I. I is equal to V by R. Therefore, I is equal to 23 ampere. Power V into I. So 23 into 23, 5290 watt. Calculate Vm, Im, omega, and the current equation and voltage equation. Voltage equation, V is equal to Vm sin omega t, I is equal to Im sin omega t. Substitute the value of Vm, Im. Therefore, equation of voltage, V is equal to 325.27 sin 3140. I is equal to 32.52 sin 3140. For purely resistive circuit, what is the value of phase angle between the voltage and current? Now, for the purely resistive circuit, when the voltage is applied, okay, the current flows through it, and voltage and current both are in phase. Means when the one cycle of voltage is completed, at the same time the one cycle of current is also completed. Therefore, the phase angle between voltage and current is 0, because as we know, V is equal to Vm sin omega t and I is equal to Im sin omega t, both are in phase. Therefore, the phase angle is 0 degree. Pure inductive circuit. Let the alternating voltage applied to the circuit. Therefore, the alternating voltage is given by V is equal to Vm sin omega t. Okay, when the alternating voltage is applied across purely inductive circuit, back EMF is induced. Okay, as a result, when the alternating voltage is applied, the alternating current flows through it, which induces the EMF. Therefore, the equation is given by E is equal to minus L di by dt. The EMF which is induced in the circuit is equivalent opposite to the applied voltage. Therefore, the equation becomes applied voltage is equal to minus E. Now, substitute the value of E in the equation 2, we will get V is equal to minus in the bracket minus L di by dt. Therefore, V is equal to L di by dt. As we know, V is equal to Vm sin omega t. Now, rearrange the terms. So, di is equal to Vm upon L sin omega t into dt, equation number 3. Now, integrating the both side of the equation, we will get integration of di is equal to integration Vm upon L sin omega t dt. Now, so take the integration. I is equal to Vm upon omega L integration of sin minus cos omega t and divided by omega. Therefore, I is equal to Vm upon omega L sin omega t minus 90 degree. As we know, minus cos omega t is equal to sin omega t minus 90 degree. Therefore, the equation becomes I is equal to Vm upon XL sin omega t minus 90 degree. Now, the current becomes maximum only when the sin omega t minus 90 degree becomes 1. Therefore, that current is the maximum current. So, maximum current Im is equal to Vm upon XL. So, XL indicates the reactance and XL is equal to omega L. Compare these two equations. So, XL is equal to omega L. So, a reactance is the opposition offered to the flow of alternating current by the pure inductance is called as a inductive reactance. So, XL is equal to omega L is equal to 2 pi Fl. Now, the value of current will be maximum when the sin omega t minus 90 is equal to 1. Therefore, Im is equal to Vm upon XL is equal to Vm upon omega L. Okay, therefore, the equation of current becomes I is equal to Im sin omega t minus 90 degree. Here, this equation indicates that the current lags by voltage by 90 degree. So, this is the phasor diagram. Now the phasor diagram and the waveforms. Now, here in this this is the voltage waveform and this is the current waveform. In the first half, okay, up to 0 to 90 degree, voltage is positive, current is negative, therefore power is negative. In this second half, 90 to 180, voltage and current both are positive, so power is positive. Now this is power in inductive circuit. For the inductive circuit, the phase angle is leading or lagging. In the inductive circuit, the current equation I is equal to Im sin omega t minus 90 degree, and the voltage equation V is equal to Vm sin omega t. Therefore, the current is lagging. These are the references. Thank you.